ensure that all roadways are forgiving. So such errors, when they occur. After I declared those fundamental principles of the passive safety, the logical conclusion would be to enhance safety by widening lanes, shoulders when they're provided, and providing a clear zone. The clear zone concept will be discussed during my lecture. So the overall conclusions. Trees, at least in the urban areas, are not the hazard that are commonly believed to be, and maybe even be beneficial to urban safety. The main issue, whether relating to urban tree or to the urban safety generally, is over major urban arterial roads. The problem is speed, especially when combined with roadway access in an urban area. Roadside safety relates to areas adjacent to the traffic lanes where an errant vehicle can recover. Providing a safe roadside involves removing likely hazards that may contribute to severity of crashes. Road crashes, to varying degree, are caused by defects attributable to the vehicle, the driver, and the road, or by combination of these defects. In addition, significant percentage of deaths on roads are a result of pedestrians being on roads, particularly in an urban environment. Crashes resulting from simply leaving the roadway, regardless of the underlying cause, represents a substantial portion of the total road crash problem. They occur on both straight and a curved section of the major urban roads, and generally involve either rollover of the vehicle or collision with a fixed object such as a tree or roadside structure. It could be a pier, or it could be a retaining wall, that could be even a building. It is thus obvious that the roadside environment and its design have a vital role to play in improving road safety, and that in the design of new major urban roads or the upgrading of the existing ones, particular attention should be given to safety as a prime design criterion. A safe road should, one, and inform road users of changes in the approaching road environment, guide and control road users safely through the road environment, provide a forgiving roadside environment, provide a control release of information, provide an aesthetically pleasant landscape, maintain road user interest and concentration, not surprise road user, give consistent messages to road users, and provide good visibility for all road users. Numerous research projects have established relationships between crashes and geometric design elements of major urban roads, as well as operating speed and traffic volumes. The various geometric design features of a road affect safety by influencing the ability of the driver to maintain vehicle control and identify hazards. Significant features include lane width, horizontal and vertical alignment, side distance, superelevation, pavement surface and drainage, influencing a number of type opportunities that exist for conflict between vehicles. Significant features include access controls, intersection design, number of lanes, and the medians. Affecting the consequences of an out of the control vehicle leaving the traffic lane. Significant features of that include shoulder width, edge drop, roadside conditions, side slopes, and traffic barriers. In addition to geometric features, a variety of other features affect road safety, including other elements of the overall road environment, such as pavement conditions, weather, lighting, traffic flows, traffic regulations, presence of pedestrians, intoxication, their intoxication and aging, vehicle characteristics such as size, mass, and braking capability. The effect of road design is somewhat obscured by the presence of these factors, and most accidents result from a combination of the factors interacting in a way that prevent a single factor being identified as a cause of a crash. However, even when a vehicle leaving the road, or when the driver error or mechanical failure, good roadside design can mitigate the severity of crashes. This interaction between road, driver, and vehicle characteristics unfortunately complicates attempts to estimate the accident reduction potential of a particular surface improvement. The construction of a road is typically a trade-off between the standard and the cost of providing this standard. High design standards might be expensive to provide. You may notice we have got desirable factors and we got absolute minimum factors. However, the cost to society of road crashes and deaths often exceeds the total annual expenditure on roads. Reducing initial construction or capital cost of major urban roads projects can result in increased life cycle cost if the cost of accidents, injuries, and deaths is included in economic calculations. It is the design engineer's responsibilities to inform a client of the consequences of inadequate expenditure on safety. It is often extremely difficult, if not impossible, to correct safety defects at a later stage without major reconstruction. If you remember, I have advised you that the various road elements are designed for many, many, many years, some of them up to 100 years. For this reason, designing for safety should occur at the outset or to be provided for in the construction stage drawings. Although most design guidelines focuses on a road design features, the psychological aspects of drivers' behavior are always present. An error in perception or judgment, or a faulty action on the part of the driver can easily lead to a crash. Roads should be designed in such a manner that only one decision at the time is required from a driver, ensuring that he or she is never surprised by an unexpected situation, that adequate time is provided to make the decision. The various research studies have shown that the number of accidents increases as the number of decisions required by the driver increases. Standardization of road design features and traffic control devices play an important role in reducing the number of required decisions, as the driver becomes aware of what to expect on a certain type of road and what to expect in the urban environment. However, it should be noted that standardization alone does not necessarily ensure a safe facility, hence the requirement for a safety audit of the design. So what are the safety objectives? Broadly, there are three avenues of actions possible for mitigating road crashes and their consequences by reducing the possibility that runoff will occur. Once the runoff does occur, by providing opportunities for the driver of the vehicle to recover and return to the road without incident, and if a crash does occur, by providing design elements to reduce the severity of that collision. The first of these areas of endeavor is a difficult and have to deal with incorporating features in the overall design of the road, which will reduce the possibility that runoff will occur. These features are influenced to a large extent by the selected design speed. Over the next 10 minutes, I will provide you advice on the two later of these three possibilities. I will provide you with a guidance on the design of roadside environment that includes elements to allow for recovery on the part of the driver, as well as the features which are intended to reduce the severity of such incidents as to occur. More specifically, I suggest to adopt the following safety objectives when a road is designed. First of all, separate potential conflict points and reduce potential conflict areas. Control the relative speed of the conflicting vehicles. Guide the driver through unusual sections. Ensure that the needs of pedestrian and cyclists, if it's relevant, so taken into account we are talking about road in the urban conditions, and we intending to provide a space for cyclists, so the cyclists also need to be considered. Provide a roadside environment that forgives a driver's errant or inappropriate behavior by attention to details, such as the safe placement of roadside furniture and by location and selection of type of traffic barriers. I would like to introduce you to forgiving roadside approach. The forgiving roadside concept relates to the approach of making provision for errant vehicle leaving the roadway by incorporating design elements that reduce the consequences of such departure. This concept is integral part of modern road design philosophy and approaches. Basically, a forgiving roadside is one free of any obstacles which could cause serious injuries to occupants of the errant vehicle. To the extent possible, a relatively flat, unobstructed roadside recovery area is desirable. And when these conditions cannot be provided, hazardous features in the recovery area should be made breakaway or shielded with an appropriate barriers. When a vehicle leaves the traffic lane, the path of the vehicle and any objects in or near the path become contributing factors to the degree of severity of the crash. By designing a forgiving roadside, the severity of the crashes can be reduced. The concept of designing a forgiving roadside should not be regarded as a byproduct of the application of safety criteria to each design element, but as an integral part of the total engineering of the major urban road. The need for forgiving roadside is paramount on the outside of horizontal curves with radii of less than 1,000 meters, which are quite common in the urban areas, where the possibility of the errant vehicle running off the road is greatest. However,